Okay, this is day 3 of improper integrals, and this is the big day where we work a little bit more on comparison tests, and I want you guys to focus on the concept of reciprocal inequalities. You're going to use that a lot. So, first we have to show that the improper integral from 1 to infinity of the differential of x over the square root of x cubed plus 1 converges. Okay, now if I look at that, I don't have any rules for this. I can't use substitution. It's not one of my inverse trig or anything like that. So yeah, I can't use substitution or my inverse trig functions right there. So looks like we're going to have to do a little comparison. But I may be able to compare this integral to and you know my favorite would be a p integral. Yep, a p integral, and make a conclusion about convergence. All right, so this is type 1 right here. All right, and here's what I have right here. So for type 1, I've got to show that it converges. That means my p would have to be greater than 1. And do you agree that my p would be 3/2? Converges. Okay, now we've got to show that this integrand, if I graphed it, would always be greater than this integrand. And that would imply that this integral would have to converge too. So, comparison. Oh, we're even going to practice what it converges to real quick here, okay? So I've got my a, which is a 1 to the 1 minus p, that'd be 1 to the negative 1/2, over p minus 1, which would be a 3/2 minus 1, or a 1/2. And isn't that just going to be a 2? Okay, so this converges implies that this integral converges, and that's all I needed to do right there is show that. QED right there. And, you know, we like to finish this off with this triple inequality to justify that. Okay, cool. All right, how about this one? Well, we're probably going to have to use comparison again. Yep. All right. And, well, how about we do this? We like p integrals, so we could we love p integrals, so we could probably compare this to 1 over root x. Okay, now do you agree that in the interval from 1 to infinity, 1 over root x would always be greater than 1 over root x plus e to the 3x. There we have it right there. Okay, so, and there's the two graphs right there if you don't believe me. All right, well, let's find out what this one does right here. Okay, so p integral, okay, and this one right here, a to infinity, okay, it converges if p is greater than 1. But isn't the p 1/2 right there? P is less than 1, so it diverges. And that doesn't help me, because if this diverges, does that tell me anything about the function is always less than it? Not at all. So, how about we use the other term and see what we can do? Yeah, we cannot use that because this integral diverges. All right, so let's do this reciprocal inequality right here. So I'm going to take root x plus e to the 3x, and that would always be greater than e to the 3x in that interval right there. All right, so now reciprocals. That means 1 over root x plus e to the 3x would always be less than 1 over e to the 3x. All right, so we better do this integral with a integrand of 1 over e to the 3x and see what happens. So e to the, how about I call that a negative 3x right there, and now I'd use substitution. So I'm going to say u equals negative 3x. The differential of u equals negative 3 dx. Now I got to do that to change my bounds. So that's going to be a negative 3 and a negative infinity. All right. And now let's go ahead and do a e to the u. And my differential of u gives me that extra factor of negative 3 I've got to undo with a negative 1/3. And I have the negative out front. So I'm going to drop that and flip my bounds. So let's go negative infinity to negative 3. And now let's figure out this one right here. So let's see, we're going to have 1/3. And then we're going to go improper integral. I'm going to have to call that lower bound r. And r is going to have to approach that negative infinity. All right. And the antiderivative of e to the u is e to the u. So we've got a 1/3. The limit as r approaches negative infinity of e to the u from r to negative 3 right there. And that's going to be fundamental theorem of calculus. 1/3 the limit as r approaches negative infinity of e to the negative 3 minus e to the r. And isn't e to the r as r approaches negative infinity approaching 0? So that's just going to be 1/3 of e to the negative 3, or 1/3 e to the 3rd. Hey, we converged. Okay, good job right there. So that converges. All right, now let's set up our little inequality right here. So what can I say about this right here then? Well, we made the statement up here that the 1/√x plus e to the 3x is always less than 1/e to the 3x. All right, so that's got to be the situation right here. And we could even put a 0 as less than over here on this side if we wanted to. All right, I like that triple right there. So I'm going to say, yep, got to converge. Pretty cool, huh? Okay, looks like we got one more problem right here. Does j equal 0 to the definite integral from 0 to 0.5 of the differential of x over x to the 8th plus x squared converge? All right, well, let's see here. We're going to have to compare that to, and probably compare it to another p integral. Comparison test, p integral, but this is one where my bound's not going to infinity. It's my integrand is approaching infinity or negative infinity when x is approaching 0. So notice that if 0 is less than x and x is less than 0.5, then, I'm going to compare these two right here. So x to the 8th would have to be less than x squared because my power is between 0 and 0.5. Okay? There. And therefore, we could say reciprocal inequalities again now. X to the 8th plus x squared would have to be less than. X to the 8th plus x squared would have to be less than. Oh, and look at this one. All right? That's unique. I'm going to compare this to 2x squared. So what I'm doing is picturing that this x to the 8th now is just x squared. All right? And look at what I have right here. So that means 1 over x to the 8th plus x squared would have to be greater than 1 over 2x squared. Okay, now does this one converge? All right, now let's think about this. So this is a type 2 right here. So for convergence, look at your rule. This is a type 2 improper integral, and p is greater than or equal to 1. So that means it's going to converge right here. Excuse me. What did I say? Okay. Diverges. Okay, so let me see. Does that help me then right here? So if this one diverges, then this one would have to diverge. Oh, but these are my reciprocals right here, so that means that would have to converge. I got it now here. So 1 over 2x, let's go. The definite integral from 0 to 2.5 of the differential of x over 2x squared. We said that diverges. Implies this one right here would also have to diverge because it's greater than that one. Diverges. Okay, so wow, are we done? Yeah, it diverges, does not converge. QED. All right, right on. Well, I think that's it. Yep, that's it. So let's finish up as many of these problems as we can right here. And we only have one more section in Chapter 8, and that will end our supplementals. So I think I'll have Malcolm give you guys a little review on Chapter 8, and then I'll give you an exam on that stuff. I'll try to make it pretty straightforward, and I'm going to only make it like 50 points, and then we will get ready for our final and finish the year. All right, you guys have a good one. I miss you so much.